All right, so this is balancing equations. This is one method of doing it with pictures. So we start off, we look at this equation we're asked to balance, and what I have here is a picture of what it currently shows. So you see H2 means there are two H's, they're connected. O2 means there are two O's connected, and H2O means there's an O connected to two H's. And just looking at this, if we divide by the arrow, everything on the left side of the arrow needs to equal everything on the right. And if you look just right now, there's more O's on the left side than there are on the right. So something is wrong here. It doesn't work. And so we got to figure out how to balance this. And one mistake a lot of people make is they say, oh, I need more O, and they just add a 2 as a subscript here. But that's not allowed because H2O2 is different than H2O. H2O is water, and H2O2 is hydrogen peroxide. And that's not what's happening here. So when you balance, you're never allowed to just change the subscripts. The only thing you're allowed to do is change the number here, called the coefficient, telling you how many particles there are. And so one way to do this is we need more O's on the right side. So what we're allowed to do is we're allowed to have more water molecules. So instead of one water molecule, I can add a second one, and now my O's are balanced. So two water molecules, look, the O's, I count them up, and I have 1, 2 O's on the right side, and I have 1, 2 O's on the left side. But I now have a new problem in that my hydrogens don't balance. On the right side, I've got 1, 2, 3, 4, but on the left side, I only have 1, 2. So I need more there. So if I double this, all of a sudden I've solved my problem, and I have 4 hydrogens there. So what does this look like in the final answer? You count how many of the picture you drew. So here I have 2 different pictures of H2, so I place a 2 out front. I only have 1 picture of O2, so I leave it blank. It's understood when you leave it blank that that really means there's a 1. So I'm just going to leave that blank, and that's that. And then water, I have 2 pictures of water, so that's what's there. So this is a balanced chemical equation. If you notice, there are equal numbers of each atom on each side. So that's one way to do it with pictures. Now, you would just have to draw this yourself until you get it to match. So I'll do a few more examples with pictures, and in another video, I'll show you another kind of way to do it. So moving on, here's another example. Once again, we're going to divide it by the arrow. And looking at this right now, neither atom is balanced if we count this up. For example, there's 1, 2 nitrogens here, but there's only 1 there. On the hydrogen side, there's 1, 2, but here I've got 1, 2, 3. So it doesn't really matter where we start. Let's pick an atom to fix. I'm going to choose to fix nitrogen first. So if there are 2 on the left, that means I'm going to need 2 on the right. And the only way to do that is I have to copy this exactly. I can't just draw an extra n. When the n comes along, the h's come for the ride. So another n, which solves my n problem, it actually makes my hydrogen problem even worse. Now I have 4, 5, 6 hydrogens. So that's more than I need to balance. But the n's are balanced, so that's good. Now to fix the hydrogens. Well, I have 2 on the left, I have 6 on the right, so that means I'm going to have to add more hydrogens. Now I have 6 hydrogens. So if I count this up, 3, 4, 5, 6, that problem is solved. So there are an equal number of atoms on each side. I have 1 of these, so I don't need anything here. I have 1, 2, 3 of these, so I have 3 H2s. And I have 1, 2 NH3s. And so that is the balanced chemical equation here. So again, by picture, this works. Everything is equal. That is a balanced chemical equation. Let's do another one. All right, Fe plus O2 makes Fe2O3. All right, so I'll just make this dividing line for myself. Maybe let's start with the iron. I have 2 irons here. I have 1 iron there. So it might make sense to add another iron. Okay, my irons are fixed. My O's are not. I have 2 on this side. I have 3 on this side. And so you might say, well, how is that going to work then? I'm not allowed to just do 1.5 oxygens. If I want more, I need to have an entire extra one. So what we can do is ask ourselves, 2 and 3, where will they meet? What number? So if I go 2, 4, 6, 8, 10, and I go 3, 6, 9, where do they meet? They meet at 6. So when there are 6 oxygens here and 6 oxygens here, now the oxygens are balanced. So that fixes my oxygen problem. If I count these all up, they're equal numbers on each side. But that did mess up my iron again. I have 4 on the right, 2 on the left, so I have to add a few more. But now it's done. How many irons do I have? I've got 1, 2, 3, 4 different ones, so 4. How many O2s? I've got 1, 2, 3 O2s. How many Fe2O3s? I got 1, 2. So that is a balance for this one. All right, one more equation like this. Actually, I'm going to skip this one and go to this. All right, so the problem with pictures is they start to get somewhat complicated. We can't do this forever because we're going to be drawing way too many things. Here's one example of one that's starting to get a little too complicated. But let's just do it anyway. We can probably do this one. So if I start with aluminum, I have 1, 2 aluminums, only 1 here. So I'm probably going to have to double my aluminum. That solves my aluminum problem. All right, sulfur. If I count my sulfurs, I've got 1, 2, 3. So I'm going to need more of these until I get 3 sulfurs. Okay. Na, if I count these, I've got 1, 2, 3, 4, 5, 6 NAs. So that means I'm going to need 6 NaCl's. It just gets to be a little tedious drawing all these. There's easier ways to do this. But if I look this over, I believe everything is balanced now. Yes, it is all balanced. So anyway, how many AlCl3s are there? There are 2. How many Na2S's are there? There are 3. Only one of these, 6 NaCl's. This is balanced. Again, this isn't even the worst of it. This is why drawing pictures, while it's good to start, once you get the hang of it, you probably want to move on. So that's what we're going to do next, is how can we do this without having to draw all these pictures. So until next time, I am Derek Genova. Have a delightful day.